Cool, let's organize this one. Let's rename this. Do remember it's generating VDBs, so this is faster. And now let's add DOP network. And we can rename this here as well. And at object level also we will rename this. So here we are creating source and DOP network inside one node only. So now let's double click over here. So we have nothing over here. First we need brain, so which is solver. So let's type sparse. So basically it's a Pyro solver and it's sparse. And let's just check inputs over here. So it has objects, advection, sourcing and forces, right? So we need object to run this. And let me again type this sparse. So I have that smoke object sparse. Let me connect this. So it's showing some domain over here, right? And let me just rename this as a dust. Cool. Let's just run this. So it's showing nothing and it's playing real fast. Let me just turn on real time. And this system is ready to simulate anything, right? And here we need to import source. And for that, we will just copy this path. And I will use volume source. And copy this over here. And I can just paste this SOP path. Now let's run this. It still won't play anything. And here we need to just call this density field inside that source. So let's just check how we can do that. So here if I select this and I can scroll down, I have that operations option. And if I click this and I can just mention source volume, and field rank is scalar. And we have two options. Vector is for velocity, which we will talk later, and source volume is density. And target field is also density. And now if I play this, it's playing over here. So Sparse solver understand this density field, right? So if I click over here, it will just take that into the system, right? But if I use density X, it will still run something, right? So as you can see, but it won't visualize or it won't advec or something, right? So it knows flame and temperature and density. And now let's just check out some parameters. So these are SOP mask, DOP mask, so which is to multiply some field. And after that we have source scale, which is, I can just reduce this. So there are a bunch of operations. So this is more like mathematics. And if you want to add or you want to keep it same, subtract and anything. For density, I want to add density. So if we are adding 1 and on next frame, it will add one more. So in total, it will be 2. But if I keep copy, it will be the same. It won't add in the system. So here I will just reset this. I want to add. And if I select the smoke object, so I have most useful parameter is voxel size. And now it's time to link this. So let me just copy parameter and paste over here. So I will use paste relative references. So the advantage of this, I can just change this over here as well. It will reflect over here. So 0.1 is fine. And second thing, I will use this same parameter to link here as well, particle separation. And I want to use half of this. So let me just divide this with particle scale. Copy and paste over here. I will have enough particles when I reduce voxel size. Cool. And now if I select Pyro solver, I have time scale and other parameters. So some parameters I won't touch as it's meant for fire, explosions and everything, right? So here I'm interested in using is shape. And here is dissipation. It will control the dissipation of dust. And disturbance, so how this works basically. As you can see, if I play this, it's static. And if I middle click, it has this active and density only. So it's showing two field only. But if I introduce this disturbance, now if I reset this simulation, I will have more, which is pressure and velocity. And let me talk about velocity only. So density cannot move on its own, right? So it needs some position shift. With the help of velocity, it will move around. So here we need to understand this velocity as the extra force, and that velocity will be added in the position of the density, right? That's how it will change position. And here, if I turn on this, it will enable some parameters here as well. And now let me just increase this to visualize this. Yep, there is some movement. Cool, this is interesting. And this is basics of Pyro solvers, how to build this. To make it work, we just need these three nodes: Pyro solver, smoke object, volume source. We will work more on this next.